All right, continuing and finishing our 8.3.2, where we're finding the equation of ellipse that's centered at any point, hk. So in exercise 39 and 46, you guys are doing 39 and 41. So for an example, I will do number 40. Okay, so our characteristics, we're given our foci and our vertices. So I put a grid here because I like to kind of plot this and see. That helps me get a picture. Like when I have a picture, everything else, I'm not so good at memorizing the formulas, these formulas and these foci. That's kind of not my cup of tea is to memorize that. But visually, that does help me a lot. So I'm going to plot my foci in blue. So I have a 2, -2, and a 4, -2. So just seeing that those foci line up horizontally, I now know that this is a horizontal ellipse. The major axis is going to be in the x direction. It's going to be a horizontal major axis, so I know it's going to be this equation. And I see my vertices are, let's see, they have the same y, which means these are going to be my major axis. So I'll do my vertices at 0, -2, and 6, -2, which is about there. So there's my major axis. I know that it's longer in the horizontal direction, again, because the foci and the vertices are lined up on the horizontal there. So my center is going to be halfway between the foci. So I can see that my center is going to be at 1, 2, 3, -2. That is, oh, sorry, not C, center. Because remember, that is the distance, actually, sorry. So then I can find C, which is the distance between the focus and center. So looking at that picture, that C is the distance between the foci and the center. Okay, so in this case, the focus and the center is a 1 unit apart, so I know that C equals 1. And A, I can find A because I found out that this is going to be a horizontal. The major axis goes along the horizontal because the foci go horizontal. So A is the distance from center to the vertex of the major axis. Vertex of major axis. I'm going to call it MA. So that's this length right here, which is 1, 2, 3. I can see that graphically. So A equals 3. So then I can get B. So I already know the width of this ellipse. I need to know how high it is. So how big is the axis? How much do I count up and down from that center? So I need to find B. So B, remember our relationship is C squared equals A squared minus B squared. So C is 1, A is 3, and B is what we need to find out. So solving for B, I'll add B squared to both sides to get B squared on the left, and then subtract 1 from both sides to get 3 squared, or 9, minus 1 is 8. So B squared equals 8. Again, I'm not going to go to find B because for the formula, actually, you know what? I will find B because I need to find Wait, do I need to graph it? No, my mistake. I'm sorry. So I don't actually have to graph it in this problem. That wasn't in the directions. I just chose to because it helps me find the relationship. But I'm just looking for the equation, so I really just need b squared. Oh, I lost my 8. There's my 8. Okay, so b squared is 8. A squared equals 3 squared, so that's 9. And c squared equals 1 squared, which is 1. So now I can fill in this formula. So my formula, remember, is x minus h squared over a squared plus y minus k squared over b squared equals 1. So the h is the x of my center, so that is x minus 3. So center is hk. And a squared is 9. And then the k is minus 2, is negative 2. So I'm going to minus a negative 2 is going to give me a plus 2. And b is the, b squared is 8, which gives me a 1. So there's my final equation for number 40. So you tried that with 39 and 41.